Maybe. Well, be proud of your drawing, no matter how rubbish it looks. Okay? Just be proud of it. Don't be intimidated by Mr. Chang. He loves to intimidate people using so many colors.
变高。他哪里？他只是初三呢。Oh no.
It's okay. I like to record what's diagram. But you said it yourself. So when we watch this in 10 years' time, you can see the horrible diagrams. That's the goal. You can play for your cats. Well, we don't know in 10 years' time if your cat will be that long. Your cat will be a granny in 10 years' time. You see, you might be smarter than I am in math, but I think I can draw better than you. No, I have to win something, okay? Just admit. I have to win something.
You have a bit of a southern.
Okay, so this is the baby complaining about the pencil case.
My curve is
Bikini baby. Birthday girl. This is some birthday diagram.
my curve is northern accent. No, northern is very.
But this looks even weirder.
I think it's a bit Canadian. It depends. North has a bunch of different ones. Like you have here. Huh? No. No one else speaks. But they all speak like this.
I don't speak.
So I'll stop in about 5 minutes so we can look at the last part of this topic, which is calculating probabilities using what you have done so far. School diagrams. They have the same.
It's okay.
Oh, something is the same. The main is the same? Oh, yes.
Not a bad thing.
明显错误。
So they're like bodies walking side by side.
Proud to be Huh? No, I have an American passport.
Really?
Yeah.
So try to extend it.
Then you're Canadian passport.
It's an accent, right?
Wow.
So you extend it.
哎，最后一个二减 mu。
That's what it is.
它 mu 是4
You're all 18 now?
2减 mu。
Really? So it's not 18 yet? Oh, so that is the babies club.
So we can deport you.
So she was the only one not 18 before until today. Welcome to the club. A round of applause. Come on, you
No,
guys
if
should clap
you
for
want
her
to get
coming
some
out to the club
deported from
18.
Singapore, you just
So this
give
is-
them- you
wait,
give them
what?
AIDS. You
She's
give them
not?
AIDS or HIV.
She thinks. Okay. Sorry, Lillian.
What?
I know you don't want to get older,
My
but
friend
you have to get
a test
older.
every single year.
帅哥，谢谢。
You go 可以啊，我可以找吗？ So if you ever want to get someone deported,
Krista,
just give them-
FYI, yesterday was the last day for you to commit a crime. Don't
It's
do it
true.
again.
It's true.
You miss your chance, okay?
初三分就变高啊，越小
So,
越
Mr.
好。
Chang, when is your 18th birthday?
My 18th birthday is after university starts.
What? After you resume?
September 13th.
对啊，
So you celebrate on
就
campus?
随便想一下，你
No,
想
I'll celebrate on Zoom. I'll celebrate on Zoom.
variance 是1的话，它是这么高的，这个是不是比1小？越小越高啊。
What's going on?
Okay.
Sketch，
Your face looks funny. I don't know what you're saying.
这个就像个。
所以我刚才跟你讲4的时候，你
我说他不知道是哪来的。
Yeah.
他那个他那
So I
个
slept with him
他
yesterday.
我知道他的，我知道那个。
It was so cool. Oh, we should have been speaking on Zoom, doing our work.
If I get into any other US schools, I would consider not going.
Okay, I think I printed too much of
But
this.
like Northeast and you know, it's not.
Everybody got one of this? Except Mr. PDF. I think you already have it. You already have it. It's the second page of the other one.
Oh, wait, let me show.
I put it on the same paper, so I just gave you in different order. Karen, this is why I didn't want you to pass it out.
Oh, yeah.
Because different paper needs to be passed out different times. So this should be on the second page. You probably have 4 copies on the second page, sorry. It's the way it was printed. I have extra, so just pretend it's food. Take extra. No, she loves food.
Oh my god, it was printed 4 times.
No, we don't. Why? No, I know you miss me on Zoom, but I have other things to do tomorrow.
Are you gonna do
Just
first
kidding.
year?
There is entrance exam
Gonna go
tomorrow.
to tomorrow?
Why we need
So we have to be in school and do grading. I would have loved to finish all this tomorrow.
I know.
You want to join?
You're going to
Then you need one.
Maybe.
You're going to UBC.
Oh, yeah,
right?
go.
Huh?
If you get
Karen, okay. I'm giving you this extra.
Oh.
Since we give you all the extra food, so you take the extra worksheet too. I think I printed more than. Okay. Let's can we look at the board for the last aspect? So there's a worksheet that I'm creating for this. I'm also looking at past questions. I have been able to compile from your book about 8 questions, 8 nice questions. From the past IB question, I only have 2 so far. So I will send it to you, not promising today, but over the weekend. Okay, you can send me some, punches on WeChat. Hey, dude, send us the question. So please remind me if I forget. But I'm still compiling. See, this is why I couldn't shut down my computer last night. Check this out.
Wow.
So I'm checking all the questions one by one to be sure they actually. So that's how I compile it. Then I need to be sure that they are in that topic, based on maybe the solution. Because sometimes you read the question. I have to work it out to be able to know this is the formula, right? But sometimes if I say that, the one of the method used is relating to the topic, then I could just pick that portion of it.
That's like me when I do my.
So I have so many stuff opened already.
Oh my god.
So I couldn't shut down my computer last night. So sorry computer, I know you haven't slept well. It's fine.
Wow.
If you ever close your computer and reopen Chrome, your computer's gonna crash.
No. My computer is not that. It's not that bad.
Your RAM will explode.
Which is why I get this.
Your RAM will explode.
So that's why I always go for like higher configuration if I need a computer. Like when I turn on my computer, within 30 seconds everything is ready. Like within 30 seconds. And I have a lot of coding application, video editing application and everything. So I like to buy a computer once and enjoy life together with it. Anyways, so quickly, there is an investigation here which we would not be able to do because of time, but I'm just going to tell you what the summary will be. So the summary is what you need to really focus on. So I've been able to summarize it also for you here. Now, initially I gave you this picture in the previous note. Now what was observed in that investigation, what you would have observed, there's no time, apologies once again. What you will have observed in that investigation is that for any population that is normally distributed with mean mu and standard deviation sigma, this is what you notice. You will notice that 68% of that population lies within the, what is this point?
The interquartile range.
The what? Point of inflection. Lie within the point of inflection, 68%. So if the question is talking about find the probability, of course you would have known your mean and mu and sigma. The questions are often related to this point, not the point in between them. They're like this distinct point that we always identify. This specific point, I mean. We always identify the mean, then the mean of the standard deviation, mean minus standard deviation. So the question you will expect are always referring to this point, directly or indirectly. I'll play you an example before we go, and that will be the last one for today. So the only thing you have to do over and over between now and your exam, because this is not in your past formula booklet, is to remember the distribution of these percentages. The bulk of it is here, 68%. Okay? Within the next deviation, you have 95% of everything. So just remember 68, 95. Understand? So if we say 68, it means there will be 34, 34 on both sides. Now, what is 95 minus 34? 95 minus 68 is what? Like, if I want to remember, if I'm writing the exam, I just need to remember 68, then 95. Understand? Now, look, come here. Brandy, can you throw that board cleaner? Thanks. So if my question is on normal probability, of course your calculator can help you. But some questions do not even require calculator because you are not given sufficient information. You might even be given in picture form. You might even be given in this form. One of the questions that I just showed you now. Look at this question, for example. Nobody said anything about the mean and standard deviation. Nothing was said about it. Okay, except that here, maybe standard deviation is say 5, for example. So it's not clear all those information that you would normally expect. But yet probability is very required to be calculated. So which is why from your knowledge of the properties of that normal curve and what we're about to do, you'll be able to solve questions like this. So please pay attention. So I will go to the exam and draw my normal curve. I will do this. Then within the plus and minus 1 standard deviation, within plus and minus 2 standard deviation. Those are the key areas that you need to remember. So this is my mu, this is my mu plus sigma, this is my mu minus sigma. Then this is my mu plus 2 sigma, this is my mu minus 2 sigma. Does that make sense? We're saying everything here is 68%. So this is 34%, 34%. Approximately, of course. Because there is some 0.0 something there, right? 0.13. Okay? But even what you remember is 68 is fine. Alright. Now, the next is 95. So what is 95 minus 68? 7, right? 2, right? If you divide that by 2, so there will be additional 27% from these two regions. That is why those were labeled 13.59. So you remember 68, 95. Does that make sense? So if I call this 13%, 13.5%, 13.5%, it will be better. It's even more better if you remember the decimal part. But I'm saying you don't have to if you can't. So the remaining is 5%, isn't it? So that's 2.5. If you combine this together, you get 2.5. Okay? So, how do we use this? Pay attention.
A continuous random variable can take any value within some interval on the number line. The normal distribution is the most famous continuous distribution. It has a symmetrical bell-shaped distribution curve. To calculate the probability that a continuous random variable x lies in a particular interval, we consider the area under the distribution curve on that interval. For example, the probability that x lies between c and d is the area under the curve on the interval between c and d. We can calculate this area using a definite integral. However, the normal distribution function has no simple antiderivative, so the calculation is done numerically. For any normal distribution, the proportion of data values that lie in certain intervals under the curve are known. Given the mean and standard deviation of the distribution, we know that About 68% of the data lies within one standard deviation of the mean. About 95% of the data lies within two standard deviations of the mean. About 99.7% of the data lies within three standard deviations of the mean. We can hence calculate the proportion of data in intervals around the mean as follows. In this example, the weight of some cans of peaches are normally distributed. The mean weight is 486 grams, and the standard deviation is 6 grams. We sketch the distribution curve for this data. We label the mean and each standard deviation away from the mean. We label the axis as weight in grams.
6 minus 6.
In
Okay.
part A, we are asked to state the proportion of cans that weigh between 480 and 486 grams. 480 grams is one standard deviation below the mean. The percentage of cans in this interval is about 34.13%, so the proportion of cans that we would expect to weigh between 480 and 486 grams is 0.3413. In part B, we are asked to state the proportion of cans that weigh more than 492 grams. 492 grams is one standard deviation above the mean. This time, we want to find the proportion of cans for an interval where only the lower endpoint is specified. So, we add the percentages in the regions to the right of 492. The total is about 15.87%. So the proportion of cans that we would expect to weigh more than 492 grams is 0.1587.
Does this make sense? So one of the reasons you will not be required to do that integral is mentioned in that audio. Because of the integral, it will be somehow tedious. Of course, we will do using calculator next time. You can actually use calculator to get your normal distribution probabilities. And that question talks about proportion. That's the same as probability. I forgot to mention the 97 part. My apologies. So if you want 99.7, sorry. Everything is 95. 99.7 means additional 2.7, right? So if you divide 2.7 by 2, that's like 1.35. And that will be, is it 1 point?
99.7.
99.7? Oh.
0.
So I mean the extra that was added up to mu minus 3 sigma. The rest is the 0 point. But I'm trying to explain this part. Okay, so I combined it at first. Okay, but it's in the note that I printed for you as well, the full details. Okay, so we'll continue with this on Monday. We're almost done. So at first we will do the calculation with what's it called? Let me quickly give you an overview of everything. So what we are doing right now is calculating normal probabilities. So we only extend it to using calculator. Okay, which is not so going to take time, just maybe first 20 minutes perhaps, or maybe 10. I'll design easy worksheet. I think this kind of worksheet helps us to move faster because everything is like ready. Then we do standard normal, something we call Z-score. So once we do that, we calculate the quantiles as well, and we are good. Okay, I can assure you we'll end everything by Monday. All right, thank you so much. We've already tried. Yes, sir.
What about Saturday?
Saturday, no, well, sorry guys, Saturday we cannot meet because we have entrance exams, so I'm going to be at work from 9 to 4. That's why. Okay. I would have loved